Apollo 11, that we would have a base on the moon, that we would be sending people to Mars. And here we are in 2019, the United States actually does not yet have the ability to send people even to low Earth orbit.
Elon Musk has just dropped a jaw-dropping revelation that could turn our understanding of the universe upside down. The James Webb Space Telescope has made a discovery on Proxima b, one that has ignited a firestorm of speculation and intrigue. What does this discovery really mean for humanity? Are we on the cusp of unraveling a cosmic mystery that could redefine everything we believe? And why should you care? Whispers from the abyss. The latest revelations stemming from the James Webb Space Telescope about Proxima Centauri b have ignited a seismic shift in how we perceive the possibility of intelligent life beyond our little blue planet. The discovery of these mysterious lights has set off a ripple effect of thought regarding intelligent life beyond our planet. This isn't just an odd scientific anomaly that can be brushed off. No, it's a potential game changer, a revelation that could redefine our quest to answer a question that's haunted humanity since time immemorial. Are we truly alone in the cosmos? Proxima Centauri b, a captivating exoplanet nestled in the orbit of the red dwarf star Proxima Centauri, stands at the forefront of humanity's quest to find extraterrestrial life. Imagine a celestial body just a tad over 4 light years away from the Earth. This prime spot within the star's habitable zone opens up the possibility for liquid water to exist on its surface, a fundamental ingredient for life as we know it. This surprising proximity doesn't just tickle our curiosity, it sets the stage for potential future exploration and groundbreaking studies that could answer some of our biggest questions about life beyond Earth. And what do we actually know about Proxima Centauri b? Why is it a big deal? Before we dive into the nitty-gritty, hit that like button and subscribe to our channel. Trust me, it's worth it. Radiation and resilience. Let's talk about a planet that weighs in at about 1.3 times the mass of Earth. That might signal a rocky makeup rather than a cloud of gas. Picture this, a solid and stable surface that we could actually stand on. Unlike the swirling storms of Jupiter, it completes its orbit around Proxima Centauri every 11.2 days, which means it zooms way closer to its star than we do to the sun. You might think that such a speedy orbit could lead to a toasty atmosphere, but here's where it gets interesting. Proxima Centauri is no ordinary star. It's a red dwarf with a range of characteristics that shape the conditions on Proxima b in specific and possibly life-sustaining ways. However, let's hit pause for a moment. There's a kicker to this cosmic tale. Proxima Centauri isn't just a gentle source of light and warmth. No sir, it has quite the reputation as a flare star. What does that mean? Well, it means that Proxima Centauri experiences sudden and dramatic bursts of radiation. These outbursts can unleash an overwhelming wave of energy that might significantly affect any planets caught in their crosshairs. Now, let's get into the nitty-gritty. Just how much radiation does Proxima b get hammered with? Brace yourself. This planet receives around 30 times the extreme ultraviolet radiation and a staggering 250 times the X-rays that Earth experiences from our sun. Ouch, right? This heavy dose of radiation raises some red flags regarding Proxima b's atmosphere. Will it be able to shield itself from these damaging rays? Can it maintain the right conditions to foster life, if life is even capable of developing there? When considering the atmosphere of Proxima Centauri b, scientists focus on several key factors. The first involves looking at whether the planet has a thick atmosphere that could provide the necessary protection against those high levels of radiation. A substantial atmosphere could also provide the greenhouse effect needed to keep the surface warm, perhaps even optimal for liquid water to flow, similar to the rivers and lakes that we cherish here on Earth. Next comes the composition of this atmosphere, which is equally important. For instance, if it's laden with gases like carbon dioxide or methane, we're looking at a drastically different environment than what we experience. The chemical makeup of an atmosphere can play a crucial role in whether conditions are ripe for life as we know it. Additionally, let's talk about tectonics. On Earth, the movement of tectonic plates is vital, not just for the shaping of our landscapes, but also for regulating our climate, recycling carbon, and maintaining diverse ecosystems. Could Proxima b have similar geological activity underneath its surface? If so, this could create a dynamic environment capable of supporting life, nurturing biodiversity across its rocky real estate. Signals from the abyss. The intrigue surrounding Proxima Centauri b just took a fascinating turn. Recently, astronomers have made waves in the scientific community by observing some truly mysterious lights emanating from this distant exoplanet. These unusual illuminations have sparked lively debates and discussions about where they might be coming from and what they could mean for the possibility of extraterrestrial life. Depending on who you ask, the interpretations of these lights vary widely, from theories about artificial origins to explanations explanations rooted in natural phenomena. When we talk about the lights detected on Proxima b, hold on to your hats because the patterns and characteristics are unlike anything we've previously seen on other celestial bodies. Preliminary data streaming in from the James Webb Space Telescope suggests that these emissions stand out not only in brightness, but also in their unique wavelengths. This specificity hints at something more organized at play, much like how our cities glow under the night sky due to intricate networks of streetlights and building illuminations. Researchers can't help but wonder, could these lights be a sign of artificial illumination? A glimpse into madness. First up, wavelength specificity. The light emitted from Proxima b seems to cluster around particular wavelengths that closely align with known spectra of artificial light, such as those we produce with LED technology here on Earth. It's as if the universe is sending us a postcard with a poignant question. Could these emissions be evidence of some sort of technological activity on Proxima b? The potential implications are simply mind-blowing if true. Then there is the intensity variability. This is where things get even more intriguing. The brightness levels of the observed lights aren't uniform. They fluctuate across the planet's surface. Such variability hints that there might be different sources or activities happening in various regions of Proxima b, reminiscent of the contrasting degrees of illumination found in sprawling urban environments here on our home planet when night falls. One area might glow with bright lights indicating bustling activity, while another region may lie in relative darkness. This leads us straight to temporal patterns observed in the brightness levels. Some observations indicate that the intensity of these lights changes over time. Fluctuating brightness could suggest the presence of active processes at work, whether they're natural or artificial. Imagine the excitement it would generate. Various scenarios could be at play. Maybe there are dynamic geophysical processes occurring beneath Proxima b's surface, or perhaps intelligent civilizations are engaging in activities that produce these lights. We're stepping into speculative territory, but is that not what makes this whole exploration so captivating? When evaluating these mysterious lights, the stakes couldn't be higher. The scientific community is actively engaged, analyzing the implications surrounding these observations. Are we witnessing a flash of intelligent life zipping through the cosmos, or perhaps evidence of geological activity that we've yet to comprehend? If these lights are indeed artificial in nature, what does it mean for our understanding of life beyond Earth? More importantly, could this knowledge reshape our view of our own existence in this vast universe? The discussion stemming from this new insight into Proxima Centauri b underscore how science is such an iterative field. With each observation, fresh questions emerge, igniting the flames of curiosity and compelling researchers to dive deeper. The convergence of astronomy and the potential for life on other planets captivates not just scientists, but also the general public. The idea that these flickers of light may be clues leading us to answer the biggest question of all: are we alone in the universe? Is an exhilarating thought. Possibility of the artificial light. Could it be that we're looking at artificial lights emanating from Proxima Centauri b? This thought-provoking hypothesis has captured the imagination of researchers who are excited about the tantalizing possibility that we might be on the cusp of discovering an advanced civilization with the capability to produce such illumination. The implications are staggering if these lights are indeed artificial, not just a flicker in the cosmos, but a signal of intelligent life beyond our planet. So, let's break down the arguments supporting this intriguing idea. First, there's the topic of technological similarities. Imagine a civilization living on Proxima b that has followed a path similar to ours. Researchers propose that if such a society exists, it might use lighting technologies that closely resemble what we've developed here on Earth. For example, if artificial lighting on Proxima b reaches about 5% of the natural daylight shining on the planet, the James Webb Space Telescope could potentially pick up on it with an impressive level of confidence, around 85%. Now let's dive into urbanization models. Scientists have crafted studies that model what a technologically advanced civilization might look like on Proxima b. What does this mean? They're exploring levels of urbanization, the architectural styles that might dominate the landscape, and the types of lighting that could be utilized. These hypothetical constructs suggest that if cities existed on Proxima b, they would likely produce light patterns that our telescopes could detect. Just picture it, shimmering lights across the planet, similar to the glistening glow of a busy metropolis here on Earth. But hold on a second. We shouldn't overlook the historical context either. The concept of discovering artificial lights in the universe isn't a novel idea. Take a moment to think about Earth itself. We're a planet that emits vast amounts of light into space, primarily due to urban development and the activities of our growing populations. Nighttime images of Earth from space clearly show the bright areas where cities reside, pulsating with life and activity. This historical backdrop supports the notion that if humans can light up their planet in such a way, surely other civilizations civilizations across the universe might engage in similar behaviors. It's a compelling argument that ties our experiences with those of hypothetical extraterrestrial beings. The cosmic alarm. Now let's explore why this conversation about artificial lights is significant beyond mere speculation. If we are indeed looking at evidence of a civilization on Proxima b, it raises a whole new slew of questions. What kind of technologies might they have developed? How advanced would their society be? What are they doing with their lights? Are they signaling something, celebrating achievements, or simply illuminating their cities for everyday use? This line of reasoning isn't just fun to theorize about. It opens the door to a new understanding of the cosmos and our role within it. Moreover, consider the impact such a discovery would have on us as a species. If we validate the existence of artificial lights on Proxima b, it would serve as a powerful reminder that we are not alone. Imagine countries around the globe uniting in celebration over this finding, reminding us all that, despite our differences, there is a shared curiosity about our place in the universe. The revelation could inspire generations of scientists, dreamers, and explorers to look to the stars with renewed enthusiasm and purpose. As researchers continue their investigations into these mysterious lights, the idea of artificial illumination is likely to remain a focal point of study. Observational campaigns will sharpen their focus on Proxima Centauri b, turning it into a virtual testing ground for theories and technological advances in space exploration. Each new observation might bring us one step closer to revealing the truth about this tantalizing possibility, generating a wealth of data that could either confirm or challenge existing hypotheses. This is where the thrill of scientific discovery lies. Every question leads to another, and new techniques evolve to help answer them. As we explore Proxima b and its lights, we're not just unraveling the mystery of one distant planet, we're also honing our understanding of the universality of life, technology, and civilization, and how these concepts might manifest elsewhere in our galaxy. Natural wonders. Let's take a step back and consider another side of the story when it comes to those mysterious lights on Proxima Centauri. While the hypothesis that these lights could be artificial has generated excitement and speculation in the scientific community, many researchers urge us to pause before jumping to any conclusions. In fact, there are several compelling natural phenomena that could explain the emissions observed, and it's important to keep an open mind about these possibilities. First up on the list of alternative explanations is volcanic activity. Imagine this: Proxima b could be a volcanic world, with eruptions that send gases and particles skyrocketing into its atmosphere. If this is the case, we might be seeing bright displays created when sunlight interacts with the volcanic materials. Just picture a vivid sunset illuminating a volcanic eruption on Earth, casting eerie shadows and glowing plumes into the twilight sky. Under specific conditions, these natural occurrences could mimic artificial lighting, tricking our observations into believing they are signs of intelligent life. Now, let's not overlook atmospheric events. The atmosphere on Proxima b is not just a backdrop, it plays an incredibly vital role in shaping what we might see from afar. Consider auroras, those mesmerizing displays of light that dance across the polar skies of Earth. Similarly, Proxima b could host its own version of auroras or other chemical reactions within its atmosphere that produce striking light emissions. The unique composition of the planet's atmosphere might lead to unexpected optical effects, especially when it interacts with radiation from its host star, Proxima Centauri. Just as our science can explain terrestrial auroras through electromagnetic interactions, we have to remember that such forms of natural beauty and phenomenon could also manifest on distant worlds. While we're on the topic of natural light displays, let's delve into the potential for reflective surfaces on Proxima b. Picture this: icy plains gleaming brightly under the sun, or mineral deposits catching the light just right, creating bright spots detectable from space. This idea highlights the fascinating ways nature can create optical illusions that misrepresent what we're viewing. Just like looking at a lake on a sunny day brings a dazzling sparkle that could be mistaken for twinkling lights, Proxima b could have its own set of reflective features, throwing off signals that experts might initially misinterpret as artificial lights. Need for analysis. This brings us back to the essential task at hand. We need to ensure that we assess the evidence holistically, rather than leaping to conclusions based on limited observations. The diversity of natural phenomena that could give rise to such light emissions highlights the vast unknowns we are still contending with as astronomers. Each proposed explanation sparks further questions and avenues for research. If volcanic activities or atmospheric events are indeed responsible? What might this tell us about the geological and chemical processes happening on the planet? Are there active ecosystems or signs of past geological activity that inform our understanding of Proxima B's history? As scientists continue to observe and analyze the data, curiosity naturally fuels the drive to investigate further. Understanding the natural processes at play could ultimately reveal a wealth of information about Proxima B's environment and its potential habitability, or lack thereof. If we can untangle these possibilities, we can paint a clearer picture of this distant world and inform future research strategies as we seek to uncover the reality behind these enigmatic lights. Let's also consider the importance of redefining our expectations. Just because we are viewing something bright and seemingly organized does not mean it originates from intelligent life. The universe is home to countless unpredictable constants and quirks that shape the landscapes we observe. As scientists, we must foster adaptability and openness to ideas about how life could manifest in ways we can't yet fathom. The possibility that Proxima B might host both natural wonders and potential signs of intelligent life opens the door to fascinating interdisciplinary debates and celestial studies. Researchers can speculate about the synergy between geological processes and biological potential. Other researchers might draw parallels between ecosystems thriving despite adversity, explaining how several factors weave into the narrative of the universe. The notion of intelligent life existing on Proxima Centauri b isn't merely an interesting anecdote in the vast narrative of space exploration. It represents a groundbreaking shift in the field of astrobiology. Can you imagine the implications if we were to definitively confirm that extraterrestrial intelligence exists? This revelation would force scientists everywhere to reevaluate and ultimately redefine their long-held beliefs concerning the evolution of life. It would fundamentally alter our understanding of the diverse nature of intelligence and the potential technological advancements that could arise from such civilizations. So why not dive into the profound implications of this discovery and explore how it could completely reshape our comprehension of life throughout the cosmos? And new frontier for astrobiology. Traditionally, the domain of astrobiology has concentrated on pinpointing very specific conditions essential for life, primarily targeting carbon-based organisms that depend on liquid water. But hold on a second, what if intelligent life actually flourishes in locales and conditions we've relegated to the impossible category? The feasible existence of life on Proxima b urges us to challenge the status quo and engage in an expansive inquiry into what constitutes life in a kaleidoscope of environments. This invites us to ponder some truly captivating questions. Could life be far more diverse than we ever imagined? What bizarre and extraordinary traits might organisms develop in environments that are worlds apart from our own? Rethinking theories. Let's unpack the enormity of this concept. If life genuinely exists on Proxima b, it could have evolved under circumstances radically different from those we observe here on our own planet. This tantalizing idea suggests that life might not just adapt, but could flourish in situations that were once thought to be uninhabitable, such as those around red dwarf stars that are infamous for their intense solar flares, radiation levels, and extreme temperatures. Who could have ever predicted that such hostile conditions might host vibrant life forms? Moreover, the evolutionary pathways leading to intelligent life on Proxima b could be fundamentally distinct from those we see on Earth. This opens the floor to curiosity about how these beings might organize socially, communicate, or even collaborate. Could it be that our anthropocentric viewpoint that human-like intelligence represents the apex of evolution needs to be drastically reconsidered? If Proxima b is home to an entirely different form of intelligence, perhaps originating from a completely alternate evolutionary history, we may have to rethink our foundational understanding of what it means to be intelligent. Let's stretch the boundaries even further. What if life on Proxima b isn't carbon-based, but relies on an alternative biochemistry? We could be talking about silicon-based life forms or organisms that not only survive but thrive in extreme, possibly even toxic environments. This broader perspective can revolutionize the criteria we apply to identify other potentially habitable planets scattered throughout the vastness of space. Just think about it, an entire universe bustling with life forms that live, breathe, and exist in ways we've yet to fully unravel. Evolutionary pathways. The extraordinary conditions that Proxima b presents could pave the way for evolutionary pathways that radically defy our current paradigms concerning both intelligence and society. So what does it mean for our understanding of life in general? To truly make sense of this, we need to delve into the influential role of environmental factors. Take tidal locking, for instance. Proxima b is likely tidally locked to its star, which means one side is forever drenched in sunlight, while the other remains enveloped in perpetual darkness. This creates striking environmental contrasts that could give rise to uniquely adapted life forms. Imagine organisms evolving specialized traits enabling them to cope with crazy temperature fluctuations. Those basking in continuous sunlight might develop natural cooling features, while those residing in eternal darkness could master ways to harness energy in creative forms. It's a thrilling two-sided coin with limitless possibilities. Now let's chat about radiation. The incredibly intense radiation streaming in from Proxima Centauri raises pressing questions about how any possible inhabitants could adjust to such a harsh environment. How in the world could they survive amidst this onslaught? Sure, developing biological mechanisms to resist radiation might be one solution, but underground habitats could less risky options, offering necessary shelter from damaging impacts. Just picture a reality where intelligent beings learn to thrive beneath the very ground they walk on. Consider this: if intelligent life does exist, their societal structures might look extraordinarily different from what we experience. The remarkable environmental pressures on Proxima b could influence cooperative behaviors that shape their cultural norms in altogether unexpected manners. Picture communities built on mutual support, where resource scarcity drives innovation in governance and social frameworks. This kind of novel thinking could flip our existing understanding on its head. A model for life on other exoplanets. What if Proxima b's unique conditions could be our gateway to understanding potential life on other planets that orbit red dwarf stars? Given that these celestial bodies are among the most prevalent types of stars in our galaxy, it's crucial we explore what Proxima b can teach us about life's possibilities in alternative environments. As we widen our search for extraterrestrial life, our findings concerning Proxima b might demand a full reassessment of what constitutes a habitable zone around red dwarf stars. If we discover that life can persist under extreme conditions that were previously deemed inhospitable, that realization could expand our criteria for pinpointing other potentially livable planets scattered across the cosmos. It is also worth noting that many red dwarf stars host multiple planets nestled within their habitable zones. Understanding gained from probing Proxima b could enrich our knowledge of these complex systems and spark future exploration missions that may uncover signs of life that we couldn't have even imagined. Let's not overlook the technological signatures we may uncover. The detection of artificial lights or other signs of technological sophistication on Proxima b could set a trailblazing precedent for seeking out similar phenomena on other exoplanets. Such an innovative approach would broaden the traditional frameworks that have mainly focused on radio signals or biosignatures alone. Looking ahead, the very thought of identifying intelligent life on Proxima Centauri b isn't just an intriguing exercise in imagination. It embodies a significant leap forward in our understanding of existence itself. As we embark on this compelling journey, the questions arising from this potential discovery lead us down fresh and exciting pathways of inquiry. How will our definitions of life evolve to encompass these revelations? What valuable insights can we extract from Proxima b that could offer models for life on other worlds entirely? The implications of these discoveries are both exciting and extensive, lifting our aspirations for future explorations of the universe. The cosmos holds infinite surprises, and we may be on the verge of deepening our understanding of the intricate web of existence. What thrilling discoveries await us as we venture into the unknown?